start the proceedings.
Thank you, sir. Good morning, everyone. Myself, Anamika Kadam, a practicing civil engineer, but now working with Larsen and Toubro. It's my privilege to introduce none other than Mr. Alok Bhumik. Mr. Alok Bhumik is President of IS Structure and Managing Director, B&S Engineering Consultants Private Limited. Has more than 40 years of design consultancy experience in transportation and infrastructure. He has accreditation of International PE and is a fellow of Indian National Academy of Engineering. He has received several awards in his professional career. In 2018, he was awarded with SB Joshi Memorial Award for Excellence in Bridge and Structural Engineering. He is an active member of several professional bodies like IEI, CEAI, IABSC, IEA Structi, ECI, and code making bodies like IRC and BIS. He is also the chairman, editorial board of the quarterly journal Bridge and Structural Engineer, published by ING IABSC. I would like to invite now Mr. Alok Bhumik to make this session, give us a good presentation, and so that we can have this webinar on. Over to you, Mr. Bhumik, sir.
Thank you, Anamika, and good morning, friends. Welcome to this webinar, which is on the topic of structural engineering for sustainable development. As many of you already know, the aims and objectives of our association, which is essentially to promote the general advancement of the science and practice of structural engineering in India. We strive to enhance the status of our profession, to promote the professional interests, rights, and privileges of structural engineers, and to facilitate exchange of information relating to structural engineering among our members. Just for information, I mean, most of you may be aware, but maybe some of you may not be aware that we also publish monthly newsletters, quarterly journals, technical journals, with very high technical content. We have published several guidelines on many important issues, like, for example, we have published the commentary on IAS 1893 Part 1 and given it to BIS. We have also developed a commentary for IS 13920 for BIS. We have published a commentary on IRC 6, which is a code on loads and load combination, which is on sale. Anybody who is a bridge engineer can, have this very useful commentary on the loads and load combination. We have published also guideline on safety audit for buildings, guidelines for proof checking, and many more. And I can tell you many of the guidelines are still in the drawing board, and another 2-3 months we will have 2 more guidelines also for the structural engineering fraternity. With this backdrop, coming to today's webinar, I think this is a very unique webinar for essentially 2 reasons. Number one, this is the first webinar perhaps where all speakers are women, and we are very privileged to have 4 eminent women speakers who have made their mark in the profession. uh, uh, the Generally we see fewer women in our profession, very unfortunately. In fact, if you go to any construction site, we hardly see any women. Of course, I have seen 1 or 2. I'm very fortunate that way. Uh, we all know that this gender inequality is all pervasive, and more so in engineering sector. Though there is an marginal improvement. When I graduated way back in 1981, in my class there were only 2 girls, and I'm sure today that percentage has increased. But still, we have a lot to do in this direction. Particularly at a senior level, I find that there is a big disparity between the numbers of men and women in senior roles. In majority of the women, I find even in senior role, they are in the HR or in the finance, but very few in, in really engineering construction sector. There seems to be a perception in the society and expectation that women will get a up to certain point only, and then once they have kids, they start working part time, and there is still a lack of value placed on these women engineers, particularly on site. And this perception needs to change. I can tell you, I have seen many women and structural engineers who are very good, very good. And they, in fact, to be very honest, in my own office, I rate them better. I mean, I hope the others are not listening. I mean, many of my women, girl engineers are performing better than their counterparts. I am telling you very honestly. I think the future perspective of IS should be to look for increased participation of women in structural engineering, and I consider this webinar as the first step towards this direction. This is my first point of today's, takeaway of today's webinar. Secondly, this webinar is on an extremely important topic, which is sustainability and role of engineers in sustainable development. We all know, I mean, the extent of knowledge may be different little bit here and there, but we all know about the climate change, which is a major issue today. The earth is now 1.1 degree warmer than it was at the start of the industrial revolution. We are not on track to meet the agreed targets, which was finalized in 2015 Paris Agreement by the United Nations. Uh, just one moment. Yeah, so in the Paris Agreement, there was a universal agreement that stipulated the global temperature to be restricted to only an increase of 1.5 degrees centigrade above the pre-industrial level by 2030. And there, till today, we have not been able to meet these scheduled targets. If you really see the history, last decade, that is 2010 to 2019, is the warmest decade on record. And the global temperature is expected to increase by 3 to 5 degrees Celsius by the end of the century, and which will be disastrous. To avoid this worst of warming, uh, the world will need to decrease the fossil fuel production by roughly 6% per year. And that is what is highlighted in that Paris Agreement. And many of you may be aware that there are sustainability development goals, 17 sustainability development goals, which India is not only a signatory but taking a lead role. But all said and done, meeting these climate change goals is a huge task, a very challenging task, and the civil and structural engineers can play a major and decisive role in reducing this carbon footprints. And in fact, I would put it this way, that this crisis is an opportunity for the structural engineers to take a leadership role in the society. We have been complaining about our poor image in the society. I would consider the climate change as one of the major sort of agenda which can change the role of civil engineers if we really take this into our hands. And I think we need to do this for the society. With this, I would now like to hand over this platform to Professor Mahesh Tandon, who is going to moderate this session. And but before that, I do that, I have the privilege to introduce Professor Mahesh Tandon, who of course hardly require any introduction. We were just casually speaking before the start of this webinar that if anybody participating here is not aware of Professor Mahesh Tandon, then he or she is perhaps not in the profession of structural engineering. The Professor Tandon is pretty well known. He is one of the giant pillar of the Indian Association of Structural Engineer. He is the past president of IES Structi, an eminent structural engineer. Many of the structures designed by Professor Tandon have been widely acclaimed and have received recognition in India as well as internationally. He has accreditation of International Professional Engineer India from Institution of Engineers. His structures have been described as highly creative, futuristic, and aesthetic, environmentally sensitive, and innovative. Professor Tandon is has made a significant contribution in the development of a culture of innovation in structural engineering, both within and outside his organization by sharing his expertise and experience. His special areas of interest also include motivating the next generation to adopt civil engineering as their profession and vocation in life. With this, I would like to hand over this platform to Professor Mahesh Tandon to conduct this show. Thank you. Sir, you are on mute. Kindly unmute yourself, Tandon Sahab.
Yes, I was muted by somebody else,
Oh,
mainly the organizers. Anyway, good morning, everybody. And thank you so much, Alok, for those a very eloquent introduction. I'm not sure whether I deserve all that, but I think that somebody has to stop sharing the screen so that I can start sharing mine. Okay. You know, I took my bachelor's degree from IIT Roorkee in 1962. At that time, there were 4 women in the whole university. At that time, it was called the University of Roorkee. And none of these women were in civil engineering. And the whole body of student body, since it consisted only of male students, wanted to attract their attention. From then, we are coming now in 2021, and things have changed so drastically. It is unbelievable. An Indian origin woman can become the vice president of the United States of America is itself an achievement. You can have the World Bank president, a woman, which could have been never thought of only till about maybe a couple of decades ago. This was something unthinkable. So it is indeed a privilege to be the moderator of an event with a difference. And I wish to thank IES Structi for having invited me to be a part of this path-breaking event. I will call it path-breaking because, as you will see, I have requested the permission to show you 4 or 5 slides to illustrate what I mean by this, why it is a path-breaking event. Diversity in such webinars is one of the responsibilities that associations like IES Structi have.
sir, kindly share your slides.
Yeah, I am just coming to the slides.
Okay.
This is the precursor of the slide. Such events can inspire many women to come forward to actively participate in such events and also join the profession of civil and structural engineering. I think it can be a cascading effect. So, with the permission, again, not yet granted by the organizers, I wish to share just 4 or 5 slides to illustrate what I've been saying in my introduction. And you'll have to tell me whether you see the slides or not.
Yes.
You do. Okay. So here we go. Let me just put it on slideshow. Okay. So today we have 4 speakers, Dr. Anal Sheth, Dr. Shilpa Paul, Ms. Anamika Kadam, and Dr. T. Visalakshi. We have a diverse topics. Alok has already told you the importance of sustainability. And these topics consist of precast concrete structural elements. They consist of dam and its foundations. They consist of digitalization in the construction industry. And the fourth one is sustainable and futuristic concrete technologies. So this is what you are going to hear in this amazing seminar today. A little bit of research in the internet after I was told that I have this privilege of moderating the presentations of 4 women. I tried to collect some data, and of course I requested my daughter, who's now a professor at the San Francisco University, to help me out. And we came up with 4 or 5 slides, which I thought I would share with you. In 2017, Air India became the first airline to fly around the world with an all-female crew. This was from Delhi to via the Atlantic to USA, and then coming back via the Pacific with many stops at that stage back to Delhi. So this was the first airline which had an all-women crew. A few days ago, there was this the 4 women that you see here, all female crew, who were responsible for the Delhi San Francisco and San Francisco Bangalore non-stop flights. I have been in this Delhi San Francisco flight, and I can tell you, I mean, something like 16 to 18 hours, depending on the which way you are going. Of course, nowadays people are going fast over the North Pole, but it is. I mean, even if you are sitting in a one of those privileged first-class cabins, it can be most tiring. And an all-female crew handling that aircraft is something amazing. This year, I hope that you see Kaun Banega Crorepati, because it has very, very enlightening insights into our country, around the world, what is happening, and so many things of general knowledge. And this year, there were 4 women only who bagged the Crorepati title and that is the current season which is going on, which Amitabh Bachchan is hosting. And you see them here. There were 4 women who won Nobel Prize in 2020. From left to right, if you see, of course, their names, some of them are unpronounceable because they are not English. Literature, and then there is a joint Nobel Prize because of the work done together on chemistry of the next 2, and physics. And if you look at it from 1895, that means 135 years ago, or 136 now, less than 60 women have been honored with this prestigious award. And in 2020, we had 4 women, which is completely out of proportion, who have got the Nobel Prize. So 4 women, I think when they get together, they can achieve almost anything. In Finland, where women have been doing well for decades now. And the 4 main ministers in the Finland cabinet are all women. And Sanna Marin, who's at the age of 34, is the world's youngest prime minister. There are 4 Indian origin women on Forbes list of top 50 women in tech 2018. They are now technology moguls in the US. Finally, I would like to talk about the women scientists of ISRO. And I have picked up this photograph, which has got all the 7 women who played a major role in 2 of our missions in space. One is the Mars Orbiter mission in 2013, and that inspired more women to enter into this, into ISRO, and to excel in the field of space research. So these are the 7 women who can be said to be the key players in the 2 space missions that we have had so far. Okay, so that's all I wanted to share about what is happening across the world and in India. And I would now like to share call the first speaker. Just give me a minute before she starts. I would like to read her CV. The first speaker of the day is Dr. Anil Sheth, Head Research and Development at Fuji Silvertech Concrete Private Limited, Ahmedabad, and a life member of IAS Shakti. Of course, we'll hear, I'm sure, more about this organization, which is dealing with precast concrete. Dr. Sheth is a leading precast design solutions provider and manufacturer in India. Previously, she was assistant professor and program chair at CEPT University for structural engineering design and infrastructural engineering and design programs. She holds a PhD in sustainable transport infrastructure from Pandit Deen Dayal Petroleum University, Gandhinagar, and an MS in structural engineering from University of Illinois, Urbana-Champaign. Incidentally, that's my alma mater also. Her graduate degree is in civil engineering from BVM Engineering College, Gujarat. And post her BE, she has participated in 40+ continuing education programs for self-development, including seminars, workshops, conferences, and webinars. She has more than 15 publications to her credit and has also organized many expert sessions, industrial visits, and study programs. She is the secretary of the Gujarat chapter of IAS Shakti, and one of her current R&D agenda is on the development of processes and documentation for the faster adoption of precast technology in the infrastructure sector. The key elements of her presentations will be the policy frameworks for sustainable development of precast infrastructure segment in the country. These will be, apart from being discussed in this presentation, I can only tell you that the Indian National Academy of Engineering has been asked to see how mass housing, which is one of the Prime Minister's favorite and most significant agenda to provide housing for all, can be implemented. And in the urban and semi-urban sector, apart from precast technology, there is no other solution. So let me stop here and ask Dr. Anal Sheth to make her presentation.
Thank you so much, sir, for introducing. Is my screen visible?
Yes.
So, good morning to one and all, and I would like to express my humblest and deepest gratitude first to Mahesh Tandon sir, Alok Bhaumik sir, for always giving this opportunity, and my colleagues here on this platform, my colleagues at the various universities I studied and worked for, my sirs, madams, my colleagues at FUJI Silvertech, where I presently work, my students, lovely girls, boys, bright, very bright, my past dean, Dr. Paresh Shah, and my current MD, Mr. Brijesh Shah, for always inspiring. And we are not born structural engineering women, or we are not born sustainability career women without the education, exposure, experience, and most of all opportunity provided by such people. So thank you. And now I start this. So basically, I'm looking for the mass use of precast concrete structural elements. I'll discuss about some prospects, plant practices, and standardization. The precast, as you already know, is not a, it's just a construction technology difference. There is not per se much structural engineering difference in precast and cast in situ, although there should be. And there is always a debate about the mass and the class, and so we discuss about the mass. I am aware that there is a total class of precast manufacturers who call themselves for specialty elements, for even heritage elements. But we are looking at the mass. I think mass is the need of our country. And also we are aware that there are in precast, there are factory or plant practices, as well as there are temporary casting yards for specialty infrastructure like chimneys, etc. So my background presently, we are looking at the factory or the plant made precast. And yes, talking about sustainability, yes, we have you know, there are many models of sustainability that we argue in theory, but ultimately it's you know, the social benefit, the economic benefit, the environmental benefit that we count and monetize. And so I really think that this is the game changer in sustainability. Many things. One is the economy, because of the saving in material, high performance material, and therefore the saving in material. We are saving the resources. We are saving the transportation by reducing the weights. The very fast construction time, and we always know there is a time value of money. Very less waste, and very clean construction on the site. Life cycle costing, if you will look for all the tangible and intangible costs that we can think of, and that is provided by the design efficiency that definitely precast can bring. Also the long service life. And you know why this precast inspires? It inspires because when we look at certain practices on the site, mostly in this forum, there are very professional and privileged people, but when we look at the site, uh, precast brings very good, smart construction practice, less laborious. It brings a good lifestyle of the engineers and of the construction workers. So I think it's a smart work. Talking about the prospects, yes, pretty much this I have sourced from the PCI, but yes, there are, you know, lots and lots of precast units now in India also, and all over the world. I think USA and Germany lead with, you know, companies that do lots of precast. In housing sector also, columns, beams, everything. Hollow core is, I think, one of the oldest precast, and I still think it's such a simple and efficient thing that was developed for floor slabs, and same for wall panels. And piles, which is a little bit of more design challenge. Uh, for transportation and bridge structures, flat slabs, curved girders, large piers, yes, precast has worked all over the world. And yes, we have the segmental construction here as well. So it works. This from my background, the company I work with is a Japanese joint venture, Fuji Silvertech, and we mainly deal with the precast drains, box culverts, retaining walls. There are over 2,000 products, but this is what I usually deal with. And as you can see, it brings a great design efficiency. It brings a great aesthetic look. These are some of the, so as you can see, these are some of the applications that I'll quickly show from the corporate world. There, where you are able to tell that not only is this good look, but I will tell you that all these times that we have monitored, they are very, very fast. The jointing technique is really simple. They are using here at this company, they are using only flange bolt connection mainly. And the jointing technique is so simple. The plant, I'll show you how the requirements at the plant are. Basically, it's going to be a very neat concreting plant. A lot of times here I have seen some 5-6 plants around Gujarat and 2 around Pune, and every time I've seen that it's a very controlled and clean plant atmosphere. So differences are only in the nature of reinforcement that they do. Here at Fuji Silvertech, I have seen an automated concreting plant and an automated rebar plant. And because the time of manufacture is so important, it is a just-in-time 5S facility. There is always, you know, just like there is a difference in the mechanical engineering precision and the civil engineering tolerances, there is always going to be a difference in the factory cast or factory made product and the site cast. And we will just have to, you know, accept and also acknowledge it somewhere that it makes a difference. Yeah, most of the time, high grade, high strength, high performance self compacting concrete works best. And you know, that also is one of the sustainability benefits, because you know, when you are going to use self compacting, you are also not going to use the vibrators. You are saving a lot on the noise pollution. Reinforcement, formwork, curing. So all these can be automatic. I mean, you really don't need a person to do any hard work here. I mean, except for the operation of the machinery or the equipment. Reinforcement assemblies that are so important can also be managed with a semi-automation. One of the very, very important needs of the precast is the nature of formwork. And I think that is also one of the major cost components. It can be up to 30% of the cost of the product if you calculate. And the finish will come. Basically, you know, at the site, we are already aware there are natures of formworks, varieties of formworks that are going on. And similarly here, what we are using is Japanese Toyota formwork. So they are very high precision forms. So formwork, I think, matters for the nature of surface finish. And yeah, and the other thing is about the built-in inserts. So there are built-in inserts, or you can inserts can be put later also, but there is an inherent strength that comes with built-in. And the typical concreting processes, the design mix, the steam curing. One of the major things is about the durability. Strength and workability we always acknowledge, but one of the major things is about the durability. And tests on durability, one of the strong things I believe is in the durability certification. There are codes and specifications that talk about the you know, durability. By durability, I would address the corrosion. By durability, I would address the chloride ion penetration or the water permeability. But there has to be a separate certification for that. And cover, I strongly believe, is not the only thing that matters for durability. Yeah, one of the other very important things about precast I thought I will put forth is about the quality. So the inspection of the material quantity as well as the production process inspection, just like it is there in the manufacturing plant, it is a heterogeneous thing. One has to correlate the drawings, production drawings, and actual process inspection and the quality testing of materials, that may be raw materials as well as, this is for the UM pipes, as you may see. So UM pipes have always been tested by full scale testing. And I remember I have you know, learned that IIT Roorkee has a very good full scale testing facility. But one needs to, a manufacturing plant needs to develop their own full scale testing facilities, and precast, I think, should be specified with respect to the full scale testing. I think it is being done in railways already. That's also I have heard for the sleepers, etc. But the specifications on raw materials is not sufficient to have this kind of processes. Yes, BIS standards on certain manholes, etc. we have, but a lot of BIS standards need to be developed for the especially precast segment. I believe one CED with the BIS is already looking into this development very fast. And also, I'm sure Alok sir, etc., are the kind of people who are instrumental in bringing this momentous change. What we follow in our organization are JIS standards, because naturally it's a Japanese joint venture. And I know that ASTM standards and British European standards exist for all these kind of precast products. Yes, separate IRC and IRS standards exist, such as IRC 112 that specify. Authorities, regulatory bodies like such as MORTH have their own specifications when it comes. One of the processes, this is the stacking and loading. So basically after the production, they need to be, so there are three kinds of strength that are important with the precast. So one is of course the final 28-day strength that we always talk of, but there is the shipping strength and there is the stripping strength. So the stripping strength is when you remove the formwork and still can tell that it's going to be in place. But the shipping strength, generally 90% of the 28-day strength is achieved within 14 days. So these can be shipped after 14 days. But also when they are put in the stockyard, there has to be, you know, they are still gaining strength. So there has to be a proper mechanism for stacking. As you can see, there is a certain height, there is a certain manner of stacking. And there has to be a well-organized specifications for stacking as well. From yeah, and also similar thing, that is the loading and unloading process, is also rotation, that basic very simple principles of the centroid and moment of inertia can make these very heavy products totally hassle free and effortless to rotate and unload. um, yes, I have known that in our organization we have transported them very far down south to Chennai, very far top north also, and east also. So this is all possible, and somehow they compete with the cast in situ very well. Uh, Lifting tools for installation are required, so that these are called D-shackles, and so that they can be lifted from the truck and put and installed on the site. So these small things matter, but these are the things which could cause a crisis if these have to be, standardization has to be with each and every item, not just the product, also the lifting tools, the safety belts, everything. The location at which you insert, and the location and the angle at which you rotate. Simple jointing techniques that we use for culverts are, this is a very simple process of laying underground. So what I mean to say is, lot of time contractors are not able to accept something that is new, because that's not what we have always dealt with. However, it is very simple, and just with a little bit of experience and little bit of one-time learning, life can be better for the installation. We use very simple the flange bolt connection, cement mortar filling, but I'll show you that there are, even if you download the pci.org connections manual, lot of connection opportunities are present in precast, and whether it is with steel or it is concrete to concrete, lot of connection opportunities. I am showing only few of them, and they can take care of the shear, they can take care of the eccentric bearings and such. Talking about standardization, at least 4 important things need to be standardized. One is the plant itself, because it's it looks like it's a very easy job to put up a plant, but if one needs to get a standard element, standard product, and standard structure or standard infrastructure, then plant certification, the nature of plant, quality control that is happening at the plant, all the procedures, assurance, random audits, frequent audits, inspections. For example, right now we are also getting the ISO 9001, 14001, 45001 certifications. There are vendor certifications and product vendor registration approval processes. Lot of quality audits come. So these things, I think, will make sure that we are always producing a standard product. Secondly, the erector certification. So what happens is, product is a responsibility of the manufacturer up to, sometimes up to the premises and sometimes up to the site. But after that, the erector or the installation personnel need to have some idea about the way one needs to install the product, because some wrong manner can lead to the whole the whole thing that is already manufactured cannot be corrected now at the site, because it's already cast, it's already hardened concrete, and also it needs to be safely handled. So there are standards and guidelines for erection of precast products, and there is erection safety manuals also. But these are not yet standardized process in our country. There are guidelines but available, which we could follow. And the other thing is about personal certification. So if you look at the PCI, Precast Concrete Institute, and this might as well be done by IS Truckee. So it's just a group of professionals who are working so actively to do certain kinds of processes. So it's not like they need the ASTM to do that. It's just a group of professional society who is doing this. So there are personal certifications for the various, how to produce the quality tests, quality inspections, loading, unloading, installation, erection procedures, the joinery, how to do that, the repair. And then, of course, coming to the structural engineering forum, where we sometimes are finding a lacuna in the design standards that are available. So, as I had, I was in touch with the CED committee on the precast with the VIS, and just for the drains product, and I came to know that one needs to write a proper document that has the types and classifications of the product, the construction drawings. IRC has very good drawings for the box culverts that are cast in the site. So similarly for the construction, for the dimensions reinforcement, there has to be a standard design and therefore standard construction drawings, standard what is the philosophy behind the design procedure, because this may be in many ways different from the cast in situ. The testing that will certify that this product is okay, including the sampling at which the core test should be done, the full scale testing, because you are doing destructive testing, should be done. Then other requirements such as the exposure, environmental exposure, corrosion criteria, cover criteria, and all the references. So this could be a possible standards development. Some things that our directors have also discussed with the NHAI, and so I have taken this permission to reproduce. So what happens in the current practice in the India is we need to have project specific approvals, but the recommended, if we could just have a standard pre-approved precast product design, just like as if there is a code, and if we always follow that, it's okay, it's acceptable, then it will reduce the project time and at the design stage. Then the multiple approval authorities. So again, we have multiple authorities that are clashing. So some standards that are internationally accepted, one time you need to check if they are applicable or if they need to be amended. But that in general, should be facilitated. The process should not stop the industry from, I believe, going forward. And therefore, our construction also, that are plans that are made, Bharatmala or whichever that are being made by the NHAI and other authorities, this should not be delayed for such reasons. And then the the high strength, high performance materials being talked about so long now. Then there is really we should just apply that and debate no more for the small costing, because the efficiency of design and the savings in the materials is much higher when you use the high strength, and cost wise it is at par with the cast in situ. And then there is a high cover of the order of 75 mm for durability. So maybe this is again a debate. GIS standards, when I was looking at, we have just 8 to 20 mm requirement, which is a huge difference, or ACI is around 19 mm requirement, which is a huge difference. So yes, but we cannot trust the practices that is there in certain developed countries and that is there here. But then we should have a durability test certification as separate. Testing may help. And by durability testing, I mean our standard tests that we specify about the water permeability, chlorine permeability, corrosion. And the product thickness also 100 mm requirement. Sometimes we come across this kind of conflicts. Whereas what we understand from the Japanese practices, we can also from the American practices that I've seen before, is that we can have a very slender elements with this kind of precast technology. And right now we have for certain products, I have learned from one of my directors that we have for the railway sleepers, but we do not have exactly the tolerance or hydraulic testing and full product structure testing requirements established, as far as I understand. Why this matters is the next point is about the Manning's coefficient that is related to the hydraulic testing. These 2 points are related. Why? Because when we are using the really good formwork, we are having a very smooth surface, and we can also have design efficiency in hydraulics with smooth surface and therefore a lower Manning's coefficient. And so it helps the client also to reduce for the same flow, same discharge we are able to achieve with smaller sections. So it helps to have a realistic Manning's coefficient. And sometimes there is a concern about 6 mm dia rebars being used. So non-structural elements, maybe one needs to do a lot of research on this, but non-structural elements for main steel and distribution steel, whether 6 mm dia should be allowed or not, because at this point also we can put a corrosion check, because I think that will be the main reason why this clause would have come into picture. And splicing and welding. So here, what happens is we are, as casting situ, a lot of times we are using the wires, whereas here we are having a 16-point welding facility, and we are actually adding the material, and we are not actually removing the metal by this. So in some of the codes, welding is permitted, but yes, I can understand why the welding concern was raised in our code. The precast plant quality system that I am talking about, it is not about, it is a really big way in which quality has to be given importance, and how the documentation set should be itself gives this is one sample of how a documentation set it should be. So I told you there's the requirement of the personal qualification. So even the quality manager, quality engineer, and all these certifications and licenses, their awareness, their knowledge about the testing. Then the task that one has to perform. Quality inspection of the product, inspection of the raw materials, the testings of the raw materials. So there is an inspection test plan form. The project quality, sometimes for particular projects, say it's a coastal project, there is a different requirement than the standard quality, and therefore the project quality communications has to be differently taken up. Some of the things help point of context. You need to have a standard laboratory for third-party testing, etc., NABL accreditation, so that then you need to have the standard material suppliers. So there is a vendor, there is a process for evaluation of the vendors. Then quality training and task training, project quality records. Quality may need to participate in the design review meeting. Then there is a manner in which they can participate in the design review. The project regulatory building codes, thought of it, quality inspection and even the safety, etc. And the quality inspection and test plan that I'm talking about, there has to be pre-pour inspections, post-pour inspections, final curing procedures. There has to be a frequency of these inspections. Although you may not inspect. Yes, sir.
Sorry to interrupt. If you could try and speed up.
Sure, sir. This is about my last slide. So product performance test procedures and quality control record maintenance and document control. Last thing that I want to say, that this is really a good career for women. Why? It comes naturally that sometimes we have different kinds of multiple tasking in our life, and therefore this is a very smart and easy work with good planning, good management skills. It's a regular work that blends with a lifestyle, systematic approaches, well defined skills building, experience matters and makes us good. There is a lot of relief in mental health, and it's not labor intensive. There is less of site work, and there is, I feel personally that there's a lot of job satisfaction, and these are various avenues at there's nothing women cannot do about. So with this, I thank everybody, and if you have any questions, you may please approach me. Thank you, sir.
Thank you, Dr. Anil Sheth, for a wonderful presentation. And just for your information, BIS has got a code called IS 15916.
Yes, sir.
And that particular code is being updated to include many of the things that you have just mentioned. And I hope
wonderful.
that Professor Prem Krishna, who is the convener of our INA precasting, or rather housing sector, where this precasting is being considered very seriously, and
Yes.
Mr. Pant, who's the head of the civil engineering in BIS, all of us are working together. And
Yes.
I'm sure that we will be getting in touch with you to see how we can bring this code IS 15916 to up to date and meeting the requirement, many of the things which you have mentioned. Thank you very much,
Thank
Dr.
you so
Anil
much.
Sheth.
It's
And
wonderful.
we will take the questions after all the remaining three speakers have spoken.
Okay.
So I would now, before I invite Dr. Shilpa Paul to make her presentation, I would like to read her CV. Dr. Shilpa Paul is the Associate Professor in the Department of Civil Engineering, Delhi Technological University, and she's also a member, a GC member, Governing Council member of the IAS Shakti. She completed her BTech from Thapar University, Patiala, and she is a MTech gold medalist from Punjab University, Chandigarh. And she got a PhD in earthquake engineering from IIT Roorkee. And just as a matter of information, I will tell you that she worked closely with Dr. D.K. Paul, the late Dr. D.K. Paul, who was loved and respected by a lot of people. She is presently working as Associate Professor, Department of Civil Engineering, like I mentioned, in the Delhi Technological University. Her areas of interest are 2D and 3D seismic analysis of dams and seismic slope stability analysis, landslide hazard, vulnerability and risk studies, application of soft computing techniques in civil engineering problems, damage detection in buildings, self-bacterial concrete. I think it should probably read self-healing bacterial concrete are some of her interests. She has published more than 50 research papers in international and national journals and conferences. She has guided three PhD students and is presently guiding 4 more, and has guided 90 MTech dissertations. She is undertaking many consultancy works, including seismic structural safety audit of buildings, third-party quality assurance work of projects undertaken by DDA, CPWD, etc. Recently, she has been awarded and working as co-investigator in a prestigious project by National Disaster Management Authority on development of earthquake disaster risk reduction index in collaboration with MNIT Jaipur. She is a member of various institutional bodies and professional bodies like ours. She has teaching experience of more than 12 years and has delivered various expert lectures and has attended and organized several workshops, training programs, etc. May I request Dr. Shilpa Paul to please make her presentation.
Thank you, sir. It's an honor to be introduced by you. And thank you to Alok Bhaumik, sir, for giving me an opportunity to present my work in front of all of you. I hope my presentation is visible.
Yes.
Thank you, sir. So today I'll be talking about the influence of modeling discontinuities in dams and its foundation. As sir has just mentioned, before I take up my presentation, I would like to dedicate my presentation to my mentor, Professor D.K. Paul. I got an opportunity to work under him, and all what I'm going to present now is what I have learned from him and worked under his guidance. It's an honor for me. The outline of my presentation is I'll be first highlighting upon what is the need of modeling, why I'm saying the modeling of the dam and its foundations. So that I'll be highlighting with the help of some case studies. And then how to model the dam structure and its foundation more accurately to get a better insight into how the dam structure behaves, both under the static condition as well as in the seismic conditions, and what are my recommendations. So first, I'd like to put up in front of all of you the failure of the famous St. Francis Dam. So this was a 200 feet high concrete gravity arch dam. You can see it was built to build such a huge structure. It takes too long, and failure of it took place in just 2 days. So it was constructed in the city of Los Angeles from 1924 to 1926, but it failed catastrophically in the year 1928, killing more than 420 people. So you can see from the slide, if you see in the slide, so this is what is the dam structure we had before the failure of the dam took place. And this you can just see what is the structure which is left after the failure of the dam took place. So that was a catastrophic failure of this type of a dam. And what was the reason behind after the back analysis was done was that this is the remaining portion of the dam, and just in a vicinity of this, there was a fault which was inactive for a certain time. It was not active, it was inactive, and this was ignored during the DPR preparation and during the geotechnical investigations. And on one side of the dam was a sedimentary rock, and on the other side of the other side of the dam, on the right abutment, was a metamorphic rock. So there were two divergent rock types which were separated by a distinct fault plane. There was a sharp contact between the two different types of rocks. Another important parameter which led to the failure was there was a hydraulic piping along the fault. Okay, and when there was a hydraulic piping along the fault, there was a cesspit bed on one side. So this was which is susceptible to disintegrate as it comes in contact with water. So there was a fault, there was a hydraulic upliftment, and there was no way to release that pressure. And as a result, the failure of the dam took place. I'll show you in my next slide how was the failure of the dam that took place. And another important reason which we normally encounter in our structures was that due to the political pressures, sorry for mentioning that, the dam height of the structure was increased by 11% without increasing the base width. So that was another one of the parameters which would lead to the failure of such a structure. Now in this slide, you can see how the failure of that took place. So this is the likely dam failure scenario, which has been put forth by the researchers, that how this failure took place. So there was a fault. So there was an upliftment which developed after the construction of the dam. And then it led to the failure of the entire dam structure. The second failure was famously known as the Vijoyne Slide catastrophe. Now, in this Vijoyne Slide catastrophe, it was a double arch dam. More interesting to note was that the dam structure, it was intact, but the structure, there was a failure along the rim of the reservoir, but the structure lost its integrity in the year 1963, killing more than 2,500 people. And which is there was an effect called the Siche effect, which is when the water sweeps across the crest of the dam. And the water, when sweeps across around 100 meters above the crest of the dam, the entire water goes to the downstream. So you can just see that it is going to wash away everything which is there on the downstream side of the dam. Why this such type of a catastrophe took place was that it was a reactivation of the old slide. Again, some fault, some discontinuity we were having in the vicinity along the rim of the reservoir, which was not taken into account as it was not active. And probably that is why the geologist or the people during the construction have ignored it. So in this slide, you can see, you can see here, this is the rim of the reservoir. This is the reservoir area, and this is the double arch dam. So there were white scars on the mountain, which is, an indication of the seepage activity which was taking place. And this was what was left after the failure of the dam. And when the large mass of the rock mass, fell into the reservoir and it swept across the water above the crest of the dam to the downstream side, and which led to the such type of a catastrophe. So there were many reasons. None of them has been accepted so far as the exact reason of the failure. Some researchers say that it is because of the failure of the slide. Some say because it is the friction values which reduce. Some say it was a seismic induced reservoir induced seismicity. So there are many reasons, but none of them has been accepted as the exact reason for the failure of the dam. Now coming on to the seismic activity. So this is about the failure of the dam under the seismic activity. So this is the famous Shishkang Dam. It was after the Chi Chi earthquake. So it was a gated spillway structure, and it failed after the Chi Chi earthquake in 1999. And now you can just see the slide. If you see, so this is the failure where the failure of that gated spillway structure took place. And you can see in this is the original elevation of the dam. And this is the height of the dam, which increased 9.25 meters because of the vertical uplift of the fault. Because there was a fault, you can see in this slide, the fourth slide, if you see, the fourth pic. So there was a Chilumpunga fault, which was going across the crest of the dam. And as a result, there was a vertical upliftment when the Chi Chi earthquake took place, and that led to the failure of this type of the dam. So just mentioned, the fault rupture with a vertical offset of 9 meters, which was responsible, and subsequent release of cubic meters of water, which was there on the downstream side. So there are n number of reasons. I had just highlighted 3. There is a Teton Dam failure, there's a Baldwin Dam failure, there's a Malpasset Dam failure, and more to number, they have failed because of the lack of understanding of the geological discontinuities and not properly modeling. So what we get to know is that the geology of the dam foundation, a very well-known fact, it is not something new which I'm telling to all of you, but it's a well-known fact, but it is ignored. And then the dam to the rock interface, I'll put in detail about what I mean by the rock interface, the geological parameters of the rock mass in terms of permeability, shear resistance, deformability. Then site investigations, yes, they are carried out. It's not again, I'm saying it's not new that it's not being carried out, but with what insight, with what detailed analysis, with the studies which need to be carried out so that it does not lead to the failure of a dam structure. Thorough knowledge of the rock structure, the types of structures and their weaknesses, and special linear or non-linear analysis techniques using like finite element method, the discrete element method, the hybrid finite and the discrete element analysis, which needs to be taken so that we come to know about the true behavior of the problem. To put forth my point, I will like to tell you how the modeling can be done so that we can mitigate it. Doing the proper modeling, doing the proper analysis, both under the static conditions, under the hydrostatic load, under the hydrodynamic loads, so we need to do a detailed analysis so that we come to know about the true failure pattern or true analysis, true stress analysis, true strain analysis of the dam. So it has been very rightly said by Ethel Mencken that for a very complex problem, because if you have a dam structure, it is a huge structure with so many complexities. But for every complex problem, there is a solution that is simple, neat, and wrong. And especially in the field of structural rock mechanics, in the field of mechanical engineering. So it has been very rightly said by Kundal and Starfield that models can be built, validated, and it can be used with conviction. And in the field of structural engineering, structural rock interaction, one seldom knows about a rock mass to model it ambiguously. So this has been said. So keeping in view of what people in this field have said, the stages, to give an overview of what are the various stages of analysis of a dam is that when the first stage takes place is the preliminary design, where the overall hydrological, topographical, economical, and even the political factors are taken into account. And in the second stage, the thorough investigations of the sites which are selected is carried out and the detailed project reports are prepared. As I have already shown you about the three failures of the dam, after going through it, I found that geological investigations are very important. And we as a civil engineer, we only teach one, we only, undergo only one subject, that too in the first or the second year, that is engineering geology. And when, or during my research work, when I started off working as a civil engineer, reading the geological drawings was very tough. So we need to do, whenever we are talking about the structures which are resting on the rocks, the detailed geological investigations, the exact mapping of the area needs to be done. And I recommend that at 20 meters interval, both in the upstream and in the downstream, so that to get a better overview of the three-dimensional 3D, what is happening beneath the rock structure, beneath the concrete structure, we need to know. The geomorphological mapping of the area, the slope classification map, yes, it is being done on all along the rim of the reservoir. The slope stability studies are done in the recent time. The detailed geological projects, as I mentioned, DPR is very important, and availability of the geotechnical properties that we get from the DPR and identification of the major discontinuities, both in consultation with a geologist who plays a very, very important role, a structural engineer and a geotechnical engineer. So they all need to join hands and identify if there are any geological discontinuities which are present on the dam site. And when we do the analysis of such a structure, the initial stage is it corresponds to the in situ site conditions prior to the dam construction, the in situ stresses which are prevailing in the foundation. Because when you're doing the blasting and everything, because of all this, there are initial stresses which are developed. So that need to be taken into account. The second stage is the dam construction, to simulate each and every step of it. Just a second. Third is the loading of the reservoir, how the reservoir loading takes place, and then it is going to encounter the hydrostatic pressure, and then the earth, then is the earthquake loading, including the hydrodynamic effects. And when we do the earthquake loading, talking about the dynamic analysis, we need to numerically model our boundaries. And Leismer and Kulmer had given a very good concept of non-reflecting or quiet boundaries or the absorbing boundaries. And we need to model it properly so that we are able to model about the seismicity of the rock mass and what is happening around the dam area. So that need to be taken into account. And you can see in this slide that in this slide you can see that you have, this is the foundation area, this is the dam portion, and this is the foundation area. Okay, then you have the free field condition. So that is how we model the free field condition. So this is called the viscous boundary condition, so that when the earthquake loading is going to come, so we are able to model it properly. And this is very nicely done in the discrete element modeling. So what are the salient features? I would like to tell you about this feature, this thing with the help of the Koteshwar Dam, which I had undergone, just a second, please. Just a second. Yes. So I would like to put forth my point with the help of the Koteshwar Dam, which I had undertaken to understand the entire behavior of the dam and the foundation. So this was a concrete gravity dam with a height of 97.5, and there were dam which was comprised of 14 monoliths, and there were no major tectonical distortions. There were no major tectonic dislocations which were there on the dam site. So this you can see is the picture of the concrete portion, the dam monoliths. This is the spillway portion, which is called the overflow sections and the non-overflow sections. There were, what is the geological rock sites? There were phyllites. And another important thing that was there were shear zones, which were there in the foundation area. So you see, like a civil engineer comes up with this, so we are not familiar with this. So we need to have a good understanding of the geological drawings which are there on the site, so that we come to know about what is happening in the something which is what is happening in the rock mass which is beneath the dam structure. So this was a general folding pattern which was there in the Koteshwar Dam. This is a dam which is on the downstream side of the Tehri Dam in the Uttarakhand. So I happened to visit the site and to identify that how the rock mass, how the jointing pattern is there in the foundation. So this was a lithological, we call it the lithological discontinuities, and where the rock mass is dipping. So these were the shear zones which are going from the left abutment, going from the dam site to the right abutment. Okay, so this was a right abutment where the lithological discontinuities are dipping. So then to understand how the behavior is there, the first model that was undertaken was a single dam monolith, which is normally the analysis way of modeling the dam monolith, that we just take a dam monolith and we apply all the loads, the hydrostatic loads, the hydrodynamic loads according to Westergaard's theory, you know, the uplift pressure that is there. So that is a normal way of modeling a dam. So just taking a single overflow and or non-overflow section, overflow which is the spillway section and the non-overflow section which is on the other side. The second model that we took was that considering the dam portion without considering that there are construction joints. Okay, so there were no joints, because when the dam's construction goes, it is not in one go. It is one monolith, another monolith that is constructed. So the second model that we took was, let's not take any dam joints, just model the dam portion. Third was consider the dam with the discontinuities that is constructed when you construct one monolith and another monolith and the another monolith. And you just see what happens. See, this is the model that you see and that we take up, that we are taking this dam portion as one, and second is the foundation is one. The foundation is one entity, the concrete portion is one entity, and what is the jointing pattern interface that we have is the concrete to the rock, only one interface. But in actual situation, that's not there. The third model that is there is, that we take that in the dam portion, you have the discontinuities, the different colors show you. And now what is the discontinuity pattern that we have? Now we have the concrete to the concrete interface. And we have concrete to the rock interface. So we have concrete and the rock interface. So in the fourth model is then you take up the discontinuities. And the fifth model that we take is discontinuities can also be identified as a lithological discontinuities or the major shear zones or the faults. So I'll now show you. Now this is a model. Now we have the dam discontinuities. Yes, we've taken the concrete to the concrete. We have the concrete to the rock interface that we've taken. Now the shear zones that were identified that are going from the left abutment all through the dam and going to the right abutment. So when they go through, you just see what is the, on the bottom figure, you can see the jointing pattern that we have. Still, that's not enough. Let's see what about the lithological discontinuities. Now you see the entire structure which is beneath, the entire structure which is beneath the dam is consisting of so many interfaces. And this is also the assumption. We have not taken the exact scenario of the jointing pattern which is there. Do the analysis, take the 3D effect of the discontinuities. So we have now three types of discontinuities: the concrete to the rock, concrete to concrete, and rock to rock. So now we have to see under the static conditions, probably there might not be any, there may be some stress concentrations, but during the seismic conditions, and this is in the Uttarakhand in the seismic zone 5. So under the seismic activity, how these jointing patterns are going to behave and how the stresses are going to transfer from the foundation to the concrete rock and then to the concrete rock, concrete, and then what happens at the crest of the dam. So this is just, I'll hurry up. I think my time is moving faster. So now you can see this is just a 3 figures under the Uttarkashi earthquake. We try to simulate what happens with the dam. Now this is the dam discontinuities. Now this is the figure. First is when you do not have a single monolith is there. Second model, when you have the entire dam portion as one entity and the foundation as one entity. This is the third, when you are taking the concrete dam interfaces and the foundation portion is there. Now you see there is no permanent displacement. When you know the crest of the dam, you have the monoliths and they are going to move as the seismic movement is going to be there. And at the crest, that is at the top of the dam portion, you can see what is the permanent displacement which is left after the seismic activity stops. So that encompasses the importance of modeling the dam discontinuities. And then also we studied about reducing the friction values, because over the period of time, when the water ingress is going to be there, the friction values, yes, are going to reduce. And then what happens? And then what is the amount of the permanent displacement which is left? So substantial increase in the crest displacement is there when with the inclusion of the dam discontinuities, because there is periodical opening and closing under the seismic activity. So we need so the dam discontinuities have a large influence on the overall behavior of the dam. Moving on to the foundation discontinuities, you can see from the slide that the transverse displacement, yes, the transverse displacement along the under the seismic activity, we have 3 motions. The transverse motion is the most predominant one, and the transverse displacement that was there when we have taken now the foundation discontinuities, you can see how the displacement increases. And also the permanent transverse displacement significantly increases. And I'll show you the figure. See, this is the shearing that takes place in the joint pattern. Okay. And this is the shearing pattern below is what happens when you have taken in the 5th model, the entire thing. And to your surprise, under the static conditions, it's okay. But under the dynamic conditions, the moment the Uttarkashi earthquake was applied, there was observed the wedge failure on the left abutment under the seismic activity. So that tells about if you are properly modeling the entire dam and the foundation discontinuities, it will give you a better insight on how to model such a large structure and to understand its behavior both under the static and the seismic conditions. So that's okay. Now, if we improve the overall strength of the foundation, we can identify the regions which are of having a large stress concentrations. Then you increase the strength by deploying all the rock strengthening measurements. And we see that if we strengthen our foundation, we can reduce the crest displacement significantly. So conclusion, with the inclusion of the foundation discontinuities, the relative transverse displacements increases. But when we change the foundation joint strength condition, increase foundation strength, it will prevent the wedge failure of the left abutment. So such studies need to be taken in detail. And what are my recommendations are the discontinuous nature of the foundation and the dam plays a very, very important role. So the study shows us about the better estimation of that the interface joint properties, the in situ conditions, they need to be known. And such type of studies need to be included in our IS code. And I am waiting for IS 1893 part 5. And whenever I have talked to my mentor, he used to say that it's in process. And I want that this study should be made mandatory under the seismic conditions. So we need to upgrade our IS codes. And let's see when it comes up and such type of studies are incorporated. And coming to the end, so Shen said that in the earlier days, slope failures can be written off as an act of God. But I say not only the slope failure, any failure, whether it is a structural failure, it's a slope failure, they cannot be written as an act of God. But today, attorney can always find someone to blame and someone to pay for the damage, especially when the damage involves the loss of life and property. So thank you for your kind attention, and let's join our hands to make our India Shikshit Bharat, Swasth Bharat, Swachh Bharat, Swavlambi Bharat, and a Sampann Bharat. Thank you so much for your kind attention.
Thank you, Dr. Shilpa. This was a wonderful presentation. And you not only talked about foundations, but so much about geology, which is, I think, as important to structural engineers as soil mechanics is. And it is a great pity that geology is not given enough importance in our curriculum and even in practice, because rarely you come across structures which have to be built on rocks. Mainly it is buildings, etc., which come on soft soil, and so we don't need to apply any of the principles of geology. But in dams, certainly, I think that it is extremely important, and I'm so glad that the part 5 of IS 1893 is in has made some progress. We have been talking about it a lot in the last few years, but we have not seen yet even the first draft. So maybe with infusion of youngsters like yourself, it will see the light of day soon. So thank you very much, Dr. Shilpa. May I now call upon Ms. Anamika Kadam to make her presentation, and I will just tell you about her a little bit. Ms. Anamika Kadam is in Larsen & Toubro. She is the DGM of that organization. She has more than 24 years of active experience in construction management of large-scale infrastructure projects, both nationally and internationally. She is well versed with all the Indian, British, and AASHTO standards, and she is currently serving, like I said, as the DGM of L&T. In phase 3A of the expansion project of Delhi International Airport in Delhi, New Delhi, as you may be knowing, which is currently being executed, she is working there. She is an active member of many professional bodies like IAS Tructee, IRC, CEAI, and ICE of UK. She has authored a number of and published a number of articles related to construction industry overall these years. She has worked as civil engineer in overseas projects in Abu Dhabi, UAE, and Oman, and closely interacted with international consultants like Arup, Hill Internationals, Covey Larson, among others. So here we have a very experienced lady who has worked in the field of construction management, which I think out of all the disciplines that we have in the infrastructure sector is the one which is way behind all the other disciplines like design and so on and so forth. And it requires, if we have to make success of infrastructure projects, I think construction management is the key. So let's hear from Ms. Anamika Kadam about what she has to say about digitalization in the construction industry. As you know, these days, and we are working in some projects where they don't even accept a drawing unless it has a BIM model. I think that all this is a part of digitalization, and we will hear from Ms. Kadam about what else is happening. Over to you, Ms. Anamika Kadam.
Good afternoon, everyone. Thank you very much, sir, for this nice introduction of mine. You are so kind of me. Let me start my presentation. My slides are visible, sir?
Yes, yes, yes.
Thank you. At the outset, I convey my sincere thanks to IAS Tructee to provide me this opportunity to present digitalization journey of construction industry, which is a need of hour for sustainable development. It's an honor to present to the august audience here in presence of Mr. Professor Mahesh Tandon and other senior experts of this forum. Let me start that the engineering, procurement, and construction industry is not well known for leveraging data effectively, nor for using cutting-edge analytics to make informed business decisions. One survey by Cornerstone Projects notes that as many as 85% of companies experience delays on construction projects. On one hand, this is understandable because after all, this is an industry where much of the work is done on the ground by workers in hard hats, not in front of computers. And on the other hand, however, it is quite strange. The projects within engineering, procurement, and construction industry impact millions of lives and run into billions of dollars. Why should this industry not get benefit from the advances in technology that other sectors have experienced? As one of Asia's leading engineering and construction companies, we at L&T Group have sought to bridge this gap. Ladies and gentlemen, when we embarked on modernizing our $10 billion construction business 4 years ago, we acknowledged the cultural issues we would need to deal into technology-related challenges. Our ultimate objective was to leverage the power of data, producing computing technologies to significantly improve core operations that utilize worker, machines, and materials to save costs, to improve productivity, and to reduce execution time. Underlying these organization goals, however, was the existential need to ensure that both management and employees on all levels, however, get engaged with these technologies and that the team could make adjustment to improve their performance based on analysis of data provided by the technologies. It took time and effort for us at L&T to help managers understand how access to real-time analytics and projects carried through an integrated mix of technologies like artificial intelligence, that is AI, the Internet of Things, that is IoT, virtual reality, artificial reality, that is AR and VR, robotic process automation, RPA, and geospatial and cybersecurity technologies could be used. All these we will be glancing through in subsequent slides, that how data-driven approach resulted in sustainability for construction business over the years. The project digitalization is started right from planning till including engineering in order to have seamless integration digitally of all disciplines involved in the project. Like for planning and monitoring, we are using Primavera, and for monitoring, we are using PM tool, BIM 4D, and live tracking. In Primavera, what we have done, that we have broken our activities till L5 level, wherein all activities which are of shorter duration, like 1 week or less, are considered and captured separately. We have also loaded resources like manpower and quantities in Primavera, which are enabling our managers to take stock of the current situation immediately. In next slide, we are showing our monitoring another tool, that is PM tool, which we are utilizing for real-time progress tracking. This tool provides us variance analysis of all aspects of EPC of our project. We can do real-time progress tracking. Live status is mentioned over here. Planned and actual status and variance analysis, as I have already told, is happening through these tools in construction projects. Another most important technology which we are using for planning and monitoring is 4D BIM. We have not limited ourselves till Primavera program and 3D BIM, but we are loading schedules as well for 4D updations, so that whatever we are executing at site is getting updated in BIM through 4D. This is our sites, being an airport site, as Professor Mahesh Tandon has introduced me in his presentation, an introduction slide for me, that I am currently working in an airport, and airport being a very important, and security concerns are so high and so many stakeholders are there. So project live monitoring is happening through CCTV images, which resulted in reducing cost of our security personnel. These images are also helping us to work towards identifying safety hazards using computer vision. So you can see how the site overall is covered, and a total 24/7 security vigilance room is there, where CCTV cameras are monitoring are happening. Now I come after planning. The next phase is engineering. So in engineering, in Dial Airport project, we are utilizing so many engineering platforms over here, like I am saying common data environment, 3D, 4D, field BIM, and AR, VR. While we have exclusive design team in the project, but we have foreign consultants also and specialized MEP work contractors operating from far off places. And in order to ensure seamless integration and flow of data to all involved stakeholders and agencies in design, we utilize common data environment in engineering. We use this data so that everyone can access centralized data across the project through 2D, 3D, and 4D drawings. Our level of detailing is LOD plus 350 in BIM, wherein our GFCs are directly getting extracted from these BIM models. We are also utilizing artificial and virtual reality modes for explanation of models to our client, which we can see here in this. To the next aspect of digitalization in engineering part. Since airport is a brownfield project, we are expanding and we are creating one more terminal for DIAL here. So considering a brownfield project, we have to integrate existing terminal building with the new terminal in terms of integration of existing MEP services and systems with the new ones. When we took up such brownfield projects, usually no as-built drawings are given to us or are available at that point in time. As for integrating existing building systems with new ones for seamless flow of services, as one integrated system of new and existing terminal, we utilize one of its kind LiDAR point cloud system technology here in design. Through this, we created virtual models of existing building and by scanning existing building. We can see here in the second photo, we are standing here in the existing terminal and scanning the existing building services. And then we are coming to our computer systems. These 3D beam is automatically getting generated through these scanned photos. And then we are integrating these services with the new proposed design systems. Now, another part which we are utilizing in engineering is virtual reality design review. It is our experience, ladies and gentlemen, that approval for finishing maximum takes maximum time. Therefore, to get faster approvals on our 2D drawings, we created virtual reality models. We made our client walk through virtually and appreciate these finishes and aesthetics. That you can see in first and second photo of this slide, and the VR models which we created here in third and fourth photo. This facilitates approvals faster from client, and we got appreciation from senior management as well, since all aesthetics and finishes are visible so clear before execution itself in design phase. Now planning and engineering is covered. I'll come to the next part, which is the construction. How you people might be wondering how the digitalization is a construction is a thing where a person has to stand there and do construction. Yes, I agree with all of you, but there are certain aspects which we can digitalize and which we can help our side to further give us the better productivity by analyzing the data which we get through these tools. What we did here, we created various mobile apps for various functions of the site, starting from safety, quality, plant and machinery till actual construction. And we made our engineers to use these mobile apps on daily basis when they are standing on their work fronts. This data is getting further analyzed through dashboards in computers, and then senior in charges are taking actions on them in real point in time. So here in this slide, we can see there are for safety, we are using safety app, IBU4U app. I'll glance each and every mobile app very quickly so that you all of you can get a quick guide how we are utilizing this. Safety app is being used extensively at site. We are recording each data and corresponding corrective preventive actions are taken swiftly by using this app. You are seeing here various analytic reports which are getting generated through the safety app. And in these dashboards, every in charge can see and analyze potential hazards which are there at site and can take action at that point of time during the day. We are utilizing for inspection of plant and machinery, IB4U app, and for the safety inspections and tracking, we are inducting virtual reality and safety induction is being happening for workmen. When we are using this IB4U app, all these are mobile apps, and when we are utilizing this, we are ensuring third party 100% inspections are happening. Manual errors in record can be avoided because every record is digitalized and recorded in the system. For quality, we are utilizing quality app, which is also mobile based app. Access is given to the site engineers. In quality management systems through digitalization, this is the analytics report which are available in dashboard, where we can manage effectively digital records of all inspections and observations. Thus, analysis of data becomes easier and resulted in improved quality at site. We can see the inspection dashboard here, where the inspections, how many inspections have happened, and this is the observation and NCR dashboard is also there, where observations and non-conformity report can also be listed here so that in charges can take action in time. Another mobile app which we are utilizing is for the workman induction and site. VISA stands for, as we can see, workforce induction and skill application. This is a digital app for workman induction. Each workman in project is tracked through VISA, which we can get the daily report by this app. Enrollment and avoid duplication of enrollment can be avoided. Digital pass is being issued to each workman, and we can see the worker history also very easily through this app. Now for survey, we are utilizing various techniques here like DGPS, GPRS survey for getting underground utilities, and stockpile measurement is being done using rover. So you can see entire air side we have mapped, and existing utilities of existing terminal we can see through these techniques. For PNM, we are utilizing important and very beneficial digital tool for the sites. All PNM assets in airside and landside are connected through IoT, and that is called Asset Insight, and analytic dashboards are being analyzed proactively by senior management. Live tracking is happening of all assets, which resulted in taking corrective actions after analyzing Power BI data for maintaining high level of utilization of each PNM asset. We can see the action which are taken after analyzing the Power BI reports. Power BI reports nothing but integrate seamlessly all operation plant and machinery at site. Rich Power BI dashboards give important insight about effective operation and utilization of PNM assets. For batching plant, also we are utilizing digital format, where all my batching plant Power BI report are getting generated there. There the production trend, working hours trend, average production, everything is getting digitally recorded over there, which is in turn helping us in identifying the usage and assessing concrete production data live using Power BI. Similarly, dashboards are also available for DG systems, concrete palms, and all other assets in the project. For payment management also, we are utilizing digitally Waybridge are connected, and there is a mobile app which is called Kaizala app, which is giving the faulty payment alerts in case of any instant faulty payment is happening. This ensures that whenever any faulty payment or undue act is reported, alert goes to all levels for immediate action. Another important tool which we are utilizing, our stores, we have digitalized our stores. Being a airport, a massive project, there 1,000-2,000 of a movement of items is happening through stores. So in order to digitalize all the stores, we have used this app Digital Store, which is in this what we do, that all our digital stores are centrally connected with each other. In L&T, it is implemented successfully, and most important benefit we realize from this initiative is that all the time we have visibility of real-time stock, inventory, data with us, so that corresponding replenishing actions are being taken in time without any shortages of material at site. Through digital store, there was much reduction in time on reconciliation. It's easier to issue the material to initiate the material for faster moving items. Second important tool which we are utilizing for project progress monitoring at site is ProCube. ProCube is a fantastic digital tool to monitor project progress on real-time basis. Planning team uploads work breakdown structures in beginning of the month in the ProCube. Once we do that, we allocate the task to particular site engineers. Site engineers submit their daily progress report in mobile every day. DPR report automatically publishes in the dashboards. At the end of the month, all project reports generated in form of various Power BI analytics data, which we can see in this slide. We can see all S curves over there, and our in charges and project managers can analyze variance between actual and planned progress at any point in time. In construction projects, we are not only monitoring our concrete, shuttering, and reinforcement works through ProCube, but all MEP and finishes activities are also getting tracked through ProCube. We made all our specialized subcontractors like Blue Star and all to contribute data for ProCube DPR. Subcontractor productivities are also getting analyzed by ProCube reports, and corresponding decisions are being made. Also at site, we are utilizing common data environment through which centralized data at site is being accessed by site engineer at 3D BIM Kiosk for review and clarity of integrated services of his area. We can see in that engineers at site, there the kiosks are installed, and they can see their BIM services of their particular area, that how the services are being there. It facilitates them to execute with more clarity. Before the conclusion part, through 4D updation in this BIM, we can get real-time progress update in virtual platform at any point in time during the day. Such walkthrough are being utilized at all levels in regular basis. So, and 4D BIM enables us to visualize complex detailing flash-free of each MEP services within any point of time in the project. So with this, I have come to the concluding part of my session today. I don't know how much justice I have made this vast subject to all of you, and how much clear I was to make my point to all of you. But being a shortage of time, let me conclude this session for today. 4 years into the process, L&T Group Engineering and Construction business is reaping the benefits of well-implemented and comprehensive data strategy. Workplaces safety has improved due to immense training with virtual reality, the use of mobile apps. Every component of project can now be measured and benchmarked, as you have seen here in my slides, leading to improvements such as a 25% increase in equipment fuel efficiency, 15% increase in worker productivity, and a 10% increase in plant and machinery productivity and utilization. While these statistics are promising, our aspiration is to improve our performance by 2 to 3% and to establish L&T as a leader in digital construction. L&T Group's journey provides a set of lessons for corporations that wish to opt for digitalization as most important sustainable tool of current times. This is all from my side today. Thank you very much, IAS Shakti, to give me this opportunity. Thank you.
Thank you, Ms. Anamika Kadam. That was an excellent presentation, and we have learned a lot about the importance of digitalization in the construction industry and what can be done with this tool. Like most of us structural engineers in the audience, they have been really been bothered about this BIM, and that's it. But it has many other dimensions, which you have explained to us as far as digitalization is concerned. So thank you very much. Let us go to our last speaker of the day, that is Ms. Dr. T. Visalakshi. Dr. Visalakshi, as most of you of IAS Shakti know, she's our honorary secretary of our organization, and she's the head of the civil engineering department of Bennett University. She has something like 15 years experience in teaching and 5 years in the industry. She graduated from the Osmania University in Hyderabad and got her PhD from IIT Delhi. Her research interests lie primarily in structural health monitoring, corrosion of RC structures, smart materials and systems, but she also has research interests in other aspects of concrete technology like geopolymer concrete, fly ash blended concrete, self-healing concrete, non-destructive techniques, green construction materials, etc. She has done pioneering work on non-destructive corrosion assessment in reinforcement bars using piezo sensors, wherein the phases of corrosion and the deterioration parameters can be identified non-destructively in complementing the existing corrosion techniques. She is a technical committee member of various national and international professional bodies, and to name the most prominent one is RILAM. And also to tell you that she has received various awards, significant among them being Best Paper at Corrosion Conference and Expo, CorCon 2012, Best Paper Award at National Civil Engineers Symposium, IIT Bombay in 2013, and Best Poster Award at ICTRAM in 2012. She's working on developing sustainable and green concrete such as geopolymer concrete, which is a cement-free concrete, and limestone calcinated clay concretes to reduce the carbon emissions for the environment. Her work also includes green wall panels and future house building materials using straw, bamboo to reduce environmental pollution. She is a co-investigator of the prestigious Imprint 2 project titled Development of Engineered Bamboo Structures, technology for modular rural housing towards sustainable built environment. So, Dr. Visalakshi, we look forward to your presentation on the future of what concrete would look like and what properties it will have. Please go ahead, Dr. Visalakshi.
Yeah, thank you, Professor Tandon, for the generous introduction. Am I audible?
Yes.
Yeah. First of all, I would like to thank IS Truckee organization, where I belong to, which also believes in gender equality, for giving me an opportunity to present before you. So let me share my screen first. So is the screen visible?
Yes, Dr. Visalakshi, it's visible.
Yeah, so let me put it on the presentation mode. Yeah. So to the audience who are present here, I would be presenting about the sustainable and futuristic concrete, how the concrete would look like in the near future. Okay, my previous speakers have talked about the core structural aspects. Okay, but I would be talking about the material point of view, which is very much important for a structural engineer in order to develop efficient designs and a sustainable designs for the future. So before moving on to the future concrete, how does the concrete look like in the future? Let's understand and go back to the history, how the concrete was developed. So in order to appreciate any latest developments, it is very important to understand from where we have come from. So let's look into the history of the concrete before moving into the future of the concrete. So as we all know that concrete is nothing but a binder material, which may not be cement as we all think of. Okay, it may not be cement, but it's a binder paste with a filler skeleton, right? As we all know that in early civilization, the prominent building material was the stone, wood, and clay. So as the human needs increased, the building materials, what you say, how we use the building materials have also developed. And the importance of how the importance of building materials can be seen that the history is being named based on the materials which we have used, such as Stone Age, Bronze Age, Iron Age, so on and so forth. So earlier it was the clay, which was mainly the binder material for the buildings which have been used. Then it was the gypsum, lime, and then the Roman civilization and the Roman concrete. They have been credited for revolutionizing the construction and the art of design. So if you look into the contributions of the Roman civilization, they have revolutionized the Western architecture. Okay, they have provided substantial technological advancements, and they have led to major developments in architecture and the engineering. Then since the fall of the Romans, concrete, there was not much development in the concrete unless the discovery of the Portland cement. So in 1824, the Portland cement has been discovered by Joseph Asphodin. Okay, the name Portland cement has been given, as we all know, that it looked like the Portland natural stone which exists in England. Then came the reinforced concrete, which has been invented in 1849. And you actually amazed to know that he's not an engineer who has invented that reinforced concrete, but he's a gardener who used to make the flower pots with the iron mesh as a reinforcement into it. Then then the first RC building was being built by William B. Wilkinson in 1854. Here, this is the first credited RC building. And then, sorry, in 1875, William Ward was the first one to build a home using RC in US. And the young engineers who have just come into the civil engineering fraternity might be amazed to know that earlier, before 1875 or before the 19th century, the concrete was not socially accepted material. It was not socially accepted. Okay, so in 1875, William Ward designed this concrete building to resemble like a masonry so that it can be socially accepted. Then in 1877, the first code was developed on cement by the German standard specifications. In 1891, the first concrete pavement was built in, was laid in US, which still exists today. Okay, and the major credit of making the concrete socially accepted will go to August Perret, who built an apartment building using RC beams. Okay, this building was widely admired, and after that only the concrete has been socially accepted by the people. It was way back in 1902. Then came the first load of ready-mix concrete, which delivered in Baltimore in 1913. And then in 1917, the National Bureau of Standards and ASTM has established the standard formula for Portland cement. Later in 1921, Fressinet has invented, and later he has patented the pre-stressed concrete technology in 1928. Okay, and if you look into after 1928, then the technological developments in concrete have been much faster, like invention of the decorative concrete, blended concretes, fiber reinforced concrete, so on and so forth. So many such inventions have come after that. But now, why we are talking the concrete and sustainability? Why there is a need to talk about the sustainability when you talk about the concrete? Why concrete is not known as a green material? Okay, so it's because the amount of concrete we utilize, it is just next to water. So the reason it is very important to make concrete sustainable for the future. And if you look into how much of carbon dioxide it emits into atmosphere, it has been said approximately that if you produce 1 ton of cement, it emits around 1 ton of carbon dioxide into the atmosphere, approximately. And if you look into the graph, just let me have the pointer options. Yeah, if you look into this this graph, the cement industry or the researchers have already realized that, and after 2013 you see a very much steady state of increase in the concrete production, cement production. The greenhouse emissions, if you look into, the carbon dioxide is the highest emitter, and out of this 72% of carbon dioxide which is being emitted as a greenhouse effect, 40 to 50% is originated from heating up the cement kiln. Okay, we can see how much concrete is contributing to the greenhouse effect. And this is the statistics related to how much exactly the emissions are being how much the concrete is going to emit into the atmosphere. And now if you see these emissions, the numbers, how much it is being emitted, how to make it sustainable? It's not a new thinking among the researchers how to make the concrete sustainable. They were working regarding this agenda since long, and many of the solutions have come up which says that make use of secondary cementitious materials in order to increase the sustainability of concrete, produce more durable concrete. That is, by increasing the life of the structure, you can make a sustainable structures. Use ultra fine secondary cementitious material, high performance concrete, higher size of aggregate, optimum cement content, recycled materials, so on and so forth. But using all these measures also, we are not able to decrease the emissions considerably. We have a decrease up to certain extent, but not considerably. So we have to look into some technological advancements in order to reduce the emissions considerably. So one of the latest technological advancement which has happened in the just in this 20th century is the development of LC3 concrete. It is a short form of limestone calcined clay concrete, LC3 concrete. So what is this concrete? So why we are looking at LC3 concrete? Okay, because we have to look into first what are the materials which are available on earth, so that we can use them and develop the concrete. So these are the percentages of the minerals which are being available. Okay, and the most useful are the calcium oxide, aluminium oxides, and the silicon oxide. And if you look into the availability of the secondary cementitious material, okay, the top ones which we are already using, silica fume, water glass, natural pozzolana slag, fly ash, so on and so forth, you can see their availability in metric ton per year. Okay, in order to meet the demand of the cement, okay, we need the secondary cementitious material which are available in plenty, not only in some parts of the world, but available throughout the world. Such a material is such a materials are the limestones and the clays. So there is no magic solution. We have to look into the materials which are available in the earth crust, right? So blended with secondary cementitious material is the best solution for the future. Okay, but the material which is potentially available in viable quantities are the best ones. Okay, and why clay? It's because it has a synergistic reaction of calcined clay and the limestones, which allows us to use in high substitution levels so as to reduce the content of cement considerably. Okay, this use of calcined clays to substitute the cement is not a new thing. It has a large history. Okay, if you look into our Bhakra Dam, okay, they have used the finely grounded calcined clays from Shivalik Hills, commonly known as Surki, okay, for the construction of Bhakra Dam. So it's not, the technology is not new. Okay, but the proportions which have been used for the replacements were not that high during those years. So the reason, this development in technology where we can use a higher proportions of these substitutions to reduce the clinker content. So the major innovation in LC3 is to combine, as I told, abundantly available low-grade kyanite clay with a further substitution of 50% of limestone, and with no reduction in the mechanical performance. Okay, the additional alumina in the metakaolin reacts with the ground limestone, leading to a very less porous material. The skin of the concrete produced using LC3 is less porous, therefore providing equal strength with higher level of clinker substitution. So clays, as we know, are the weathering products of all rock types and abundantly available close to the Earth's surface in all geological settings throughout the world. The clays which we use for which are being used for the development of the limestone calcine cement are the clays which have which are much what you say impure sort of clays. Okay, the kaolinite content needed for LC3 is much lower than the pure kaolinic clay, which are being used for the ceramic and the paper industry. We are not going to use the pure kaolinic clay. Okay, so use of such low grades would not compete with the demand of the resources which are being used by the other industries. In India, abundant amount of low grade clays exist as an overburden in existing quarries or currently regarded as a waste. So use of such resources would neither require opening of new quarries nor they deplete the agricultural soils. So they are very much competent material to be used as a secondary cementitious materials in higher proportions. So if you look into why LC3 again, okay, so it allows growth without abstinence due to the resources and also with lower emissions. So if you look into the how are the emissions related to LC3 are being concerned, they are very much lower than 20 to 30% with respect to the Portland cement. Why it is because of the reduction of the clinker content. Since we reduce the clinker content, less process emissions and the less heating of the limestone. And the other important point with the LC3 concrete is that the existing equipment of the cement industry, which can be used, okay, only a marginal increase would be equipment for the calcining the clay. Only a marginal equipment needs to be added into the existing system of the cement manufacturing industry. So lower cost of production, it's because we are using the reduced clinker content, reduced fuel consumption, so on and so forth. And LC3 technology is also a well-known technology because the clinker limestone system and the clinker calcine clay systems are very well established in the research fraternity and aware of. Okay, in effect, LC3 optimizes the synergy between the two already known chemical systems. Resource efficiency, because we use the low grade clay and limestone, it doesn't require opening of the new quarries, as I told you earlier also. So as a result, LC3 is very attractive and feasible option to satisfy the development and the environmental objective. So it's a human mentality that whenever a new technology is being developed, we need to compare it with the existing one so as to know its advantages and the look-and of it. So if you look into the compressive strength, which is very important for any concrete, the LC3 has, if you look into the equivalent strength grade category, the compressive strength of LC3 is similar to that of OPC and better than the fly ash blended concrete with 30% replacement. If you look into the common mix category, LC3 shows better strength development than the OPC and the FA30. Elastic modulus is very much similar to OPC. The shrinkage is a bit more in LC3 as compared to OPC and FA30, which is a Lucane. And studies are going on how to rectify this, okay, and which is the drawback and which is being looked upon to by the researchers. And the refined pore structure is very good for the LC3 concrete, and which is the reason for its better durability performance than the OPC and also the fly ash blended concretes. The surface resistivity is very high as compared to other mixes because porosity is highly refined, which would protect the steel better. The chloride ingress, it has the highest resistance even at early stages, and the LC3 system requires a shorter curing period than the Portland pozzolanic systems. If you look into the strength, as I told you, LC3 is equal to OPC and higher than FA 30. And LC3 exhibits lower variability in chloride profiles when compared with the ordinary Portland cement and the blended cements. In LC3, the chloride threshold is also lower, and the chloride-induced crack resistance is better than the others. But if you look into the carbonation resistance of LC3, since it contains lower Portlandite content, okay, the carbonation resistance is bit lower compared to that of the other conventional OPC or else the FA blended concrete systems, okay, which is also been researched to improve it by the research community. And the LC3 concrete system also what you say is in line with the sustainable development goals. The LC3 system contribute for the 5 sustainability development goals which have been given by US. Okay, the first one is number 9 related to the industry, innovation and infrastructure, and it also fulfills the sustainability goal number 11, building sustainable cities and communities. Goal number 12, responsible for consumption and production. Goal number 13, related to the climatic action. And goal number 17, related to the partnership for the goals. And if you look into the field application of this LC3 cement, okay, a house, the first house is been built in Cuba at Santa Clara using this LC3 cement. Okay, in our own Dadri plant, LC3 cement blocks are being developed at KJS Concrete Private Limited. And this is a demonstrative structure which has been built using LC3, and it also done the CO2 emissions calculations and found that around 7 tons of carbon dioxide has been saved compared to the existing solutions. So with these advantages, I think the structural engineers and the civil engineering community have to understand about this concrete system and look forward to work with this system. The second system which I'm going to talk about is the geopolymer concrete system using fly ash. Now, again, before going to the why geopolymer concrete using fly ash, let's look back to the history, how this geopolymer concrete has been developed. Okay, what is geopolymer? Geopolymer materials represent the latest advancement in the aluminosilicate chemistry, which was first investigated in 1930s. Okay, after 2 decades of that, the research are focused on development of zeolites and alkali activated materials, which can react with aluminosilicate when mixed with alkali liquids. So during 1970s, Professor Davidovich, who has coined the name geopolymer concrete, okay, he defined the geopolymer chemistry with his first work on kaolinite, which paved the way for the establishment of geopolymer chemistry. He's known as the father of geopolymer concrete, and he's the one who has pioneered this technology. First geopolymer cement was developed and patented by Professor Davidovich and say in US, and it has been named as Hurley high strength mineral polymer. Okay, since then this technology, geopolymer technology as a building material, has gained significant ground in sustainable infrastructure. And the main advantages of this geopolymer concrete is that it doesn't use cement at all. It is a cement-free concrete. So what are the source material it requires? So it requires aluminosilicates, the materials which are high in alumina and silica, such as calcined clays, keolinite clays, laterite clays, volcanic rocks, or industrial byproducts such as fly ashes, blast furnace slag, so and so forth. Okay, and in order to activate these materials, we need user-friendly alkali reagents such as sodium silicates, potassium silicates, etc., and then water. Okay, then the combination of these three mixes will produce a geopolymer cements. So now geopolymer, we can use any material which is rich in aluminum and silica, but why fly ash? Because in India, as we know that the fly ash is abundantly available. Okay, there is a long gap between the generation and the utilization, and there is an ample scope in the future also to utilize the fly ash. So hence, and if you use geopolymer concrete using fly ash, it will address two important issues such as greenhouse emissions and also reduction in energy requirement, and also disposal of this fly ash into the environment. This is how the geopolymer concrete chemistry would look like. Okay, first the source materials, whatever you use, whether you use the keolinite clays, the waste products such as blast furnace slag or the fly ashes. First the process is the dissolution, then the equilibrium takes place, gelation, reorganization, then there will be the polymeric chains which form and give the strength to the cement. Okay, and if you can observe here, at each and every stage the water is being released. So this geopolymer system, which has a chemical reactions very much different to our conventional ordinary Portland cement reaction. So it is very important for us to understand the chemical reactions of the geopolymer concrete, because we are well versed with the ordinary Portland cement reactions, and this is a very new technology and need to understand that. And these are the SEM images, how the fly ash particle which dissolutes into the alkali liquid and forms a thick dense layer. And if you look into the size of the geopolymer missile which is been formed after reacting with the alkali hydrates, if you look into, this is a size of your fly ash particle, size of the silica fume particles, and this is a colloidal silica, and here comes our geopolymer size after reacting with the alkali liquids. And if you compare the properties, the mechanical and the hardened properties of geopolymer concrete, okay, it possesses high early strength. The geopolymer concrete, you can get the required strength in 3 to 5 days using this geopolymer concrete, where the ordinary Portland cement concrete would require around 28 days to get that. So resistance to freeze thaw, sulfate attack, corrosion, fire resistance, they are all being improved when compared to ordinary Portland. There's no dangerous alkali aggregate reaction in geopolymer concrete. And you can see the geopolymer cement can harden rapidly at room temperature and gain a compressive strength in a range of 20 MPa after only 4 hours. And geopolymer cement is found to be superior to Portland cement in terms of heat and fire resistance. As you can see that in an OPC, we can see a sufficient deterioration in compressive strength at around 300 degrees centigrade, whereas the geopolymer cements were stable at around 600 degrees centigrade too. They have extremely low shrinkage, and geopolymer cements with much higher alkali content compared to OPC doesn't generate any dangerous alkali aggregate reaction as OPC. And as we have seen in the chemical reaction, the water is released during the chemical reactions that occurs in the formation of the geopolymers. Okay, this water is expelled from the mixture during the curing process. Unlike ordinary Portland cement, which utilize water in order to form that CHS gel, which is important for the strength gain. But geopolymer concrete utilizes the polycondensation of the silica and aluminum precursors and the high alkali content to attain the structural strength. And this is the chemical reactions of the ordinary Portland cement to the left and the geopolymer concrete to the right. You can see how the polycondensation happens and the polymeric chains are developed, which ultimately gives strength to this concrete. And if you compare the strength, as I told, both the strength are compared to each other. In fact, a high early strength is attained in geopolymer concrete. And if you look into the durability aspects, the corrosion experiments conducted in the laboratory found that after around 120 days of accelerated corrosion exposure, normal concrete specimen was found to be in cracking phase, and the blended fly ash blended concrete specimen was found to be in the propagation state, which is the second phase of corrosion. And geopolymer concrete, there were no signs of corrosion products on the surface, and they were found to be in just the first phase of corrosion, which is the corrosion initiation phase. So from this, we understand that the geopolymer concrete has better durability than the other conventional concretes. And also the corrosion rate of GPC is very low when compared to the normal and the blended concrete. If you look into the application part of this, field application part of this geopolymer concrete, very recently NTPC, Netra and CSIR, Roorkee, they have developed high strength fly ash based geopolymer concrete for the construction of road pavement, which has been laid for a stretch of around 50 meters length and 3 meter wide with 40 MPa GPC as per the IRC specifications. And Australia has pioneered this technology, and Wagner's Private Limited is a company which produced this geopolymer concrete. So they have in 2013, they have constructed the first building, public building, that is the Global Change Institute in Brisbane, which is entirely made using geopolymer concrete. And in Australia itself, in 2014, they have constructed the West Wellcamp Airport in Brisbane using this geopolymer concrete, and the same company, Wagner's, have built this. And in Siberia, the first geopolymer 3D printed house is been constructed. And recently, very recently, Sydney launched its first trials of public road construction using this geopolymer concrete. And Russians, they have built a pedestrian bridge and a foundation of Gazprom neft storage facilities using this geopolymer concrete very recently. So it's gaining ground in countries. So I acknowledge my supervisors, Professor Bhala and Ashok Gupta, for what I am today. They are the supervisors of my PhD. And most of the work which I have presented are from my students, and the Rylam CCL, calcium clay supplementary cementitious material committee. Some of the slides which I have taken from, and I acknowledge all these people for the presentation which I have made. And thank you so much for your patient listening. I think that I have introduced new materials for the structural communities to look upon and include in their designs. Thank you so much.
Thank you, Professor Visalakshi. That was a wonderful presentation. And it was good to hear that the future of concrete is safe in the sense that it may not even have cement, it will have something else. So that is very nice to hear. And of course, we have to have some part to play as far as sustainability is concerned. And if we can have a material which is equally good and shrinks less and gains strength faster, gains higher strengths, I mean, what can be better than that? We are all looking forward to learning more about it. You have introduced the subject, and
Yes.
maybe in one of these future webinars or lectures, we want to hear a little more about its application to real structures. You said that a couple of structures have been made. That's very nice. And it has also been used in 3D printing, this geopolymer.
Yes.
So I think all this requires to be absorbed a little more slowly. I think you went too fast for us, many of us to absorb.
Yes, yes, because the time given to me was only 20 minutes, so have to at least introduce the technologies
yes.
to the people. Then later we can take one by one in detail.
Yes, I think you did a wonderful job in the 20 minutes. So I think that there are a very large number of questions that have been generated. So without wasting any time, let us take a few. And of course, these questions have come more or less in the order in which the presentations were made. First one is from Mr. Deepak Bansal. When you said that high compacting concrete is sustainable because this does not require compacting, what embodied energy is this concrete has? I mean, that's a question. I mean, it has less embodied energy because you don't have to compact it, but he's talking, I think, about quantification of that.
Yes, the mechanical energy. Right, sir. Right, sir. Yes, embodied energy. But you know what? Embodied energy, why we are thinking that there is really, when it comes to human values, the embodied energy of labor, etc., we are not even accounting properly.
Yes, yes.
That is one thing. And yes, the energy that is related to this electrical energy, mechanical energy, but you know that we'll have to see that energy actually, as we know, is only a transfer from one form to another, and sustainable forms of energy are taking place, solar, etc. So it will be, yes, it is not true right now, but I think it will happen.
Okay, second question for you, Dr. Anil Sheth, from Mr. Sushil Dhawan, who is our champion questionnaire in every seminar.
Yes, concrete. Yes.
He is saying service life of precast concrete construction, how does it compare with cast in situ from durability and sustainability point of view?
Sir, seen from what I have read in the literature, there is a vast difference. We are having a minimum warranty period of 5 years, and we are having a life cycle assessment of 50 years. As such, when the culvert goes in place and it's an underground structure, we cannot expect, we don't expect all these things to be dug even after 100 years. So precast, definitely we can account for at least a 50 years life cycle, whereas we have looked into certain case studies at our own end into the this maintenance requirements, annual and 5-yearly, and major maintenance and regular maintenance requirements. But definitely I'm convinced now that precast has better life than much longer life. It is you can compare from anywhere for 5 to 10 years for cast in situ is about 50 to 60 years for precast. But that when you say life cycle cost assessment, you have to count over the maintenance periods.
Of course.
Yes, sir.
There is a question from Mr. Mahesh Singh Rathore. What about the earthquake resistance of precast members? Any special measures for multi-storied construction in Zone 5?
Uh,
I mean, do you use?
not
Yeah, please.
Yeah, sir, construction, the cast in situ details and the precast details can be very similar. What we can do, it is what matters is only where they are cast. So, but it has to be pre-planned. Definitely, the detailing it can be done in the same manner as we do for cast in situ, but it has to be pre-planned. That's a major difference. But dowels for I have seen case studies where dowels are not sufficient, and there are two kinds of things in the precast that I have learned from the Japanese. That one is how to increase the stiffness. So it's not because of the flexibility approach. It's because how to increase the stiffness. Smaller members and connected to each other. So they provide beams at small spacing, which actually may increase the amount of concrete that can be consumed. So in seismic conditions for high story, I think it will be they will be narrow members, but they will be very close to each other. The other thing, dowels, I have seen that is that they are doing both horizontal as well as vertical connections, but actually I have no calculations for that, for buildings.
Okay. But what buildings what elements do you think that can be precast in these tall buildings? Are there any specific elements that you would recommend?
Yes, sir. In fact, definitely, sir. In fact, in the US, all the projects that I did, they were all buildings, and they were so floor panels precast. It will make a lot of sense. Even wall panels precast make a lot of sense. So, but these are hollow core, and the reinforcement bar runs through and through, and then there is the micro concreting or grouting that can be done. But here we have in seismic, but those things were not in high seismic zone. There's detailing as well.
Okay, another question for you is what measures do you take for reducing temperature rise and gradient?
Columns,
Ah.
columns,
I think your voice is gone.
I think her signal is not there.
I think some problem of signal.
You can take other questions, sir.
I think I'll take, yeah. So for Dr. Shilpa Paul, has fault analysis been done for Tehri Dam?
Yes,
this
sir,
is from Mr. Deepak Bansal.
Yes, a thorough study has been done. It was done by my mentor, Professor D.K. Paul. So a thorough study of the fault analysis has been done for the Tehri Dam as far as I know.
Okay. Mr. Vipul Ahuja, one of our
hello, sorry,
stalwarts.
Yeah, sorry, I could lost connection.
Yeah.
Yeah, just I was saying that one is the property of concrete, that is a good having better than steel at least, and when it is underground, the temperature variation, I find it I did some calculations and I find it very unrealistic, even for pavements. Some pavements also I have done where we had a temperature that was the load side, in Urbana we had almost 3 feet frost depth. But so cracking, yes, but that is when it becomes on the lower side. But I think in our general range we will snow regions one has to investigate. But in general case, this would not be effective. underground as such, there is a lot of earth cushion.
Oh, okay, so I think that Mr. Vipul Ahuja's question, how did you calculate the dashpot properties for the free field in your dam model? That is for Dr. Shilpa.
So, to answer this, for the dam analysis, 3D dam analysis, which we have carried out, in that we use the viscous boundary conditions, not the free field condition. The viscous boundary condition is that if you have the earthquake coming, let's say this is the boundary. So we assume that whatever seismic excitation is coming, that is being absorbed by this boundary. So all the three faces of the foundation, so the absorbing boundary conditions were assumed, and that has been integrated in the software itself. So I did not go for the free field, so that I could give the stiffness properties both in the normal and the shear direction and damping properties. So I had not used those in my model, but yes, that is one parameter that can be taken into account. But for me, I have done the Lismer viscous boundary conditions.
Mr. Vipul Ahuja has asked one more question, or I don't know whether it's a comment. For years, we have been talking about the teamwork of geological and geotechnical engineers for every building construction on a slope. For example, in Shimla, we may have a new building constructed on a hillside. When a geotechnical report is done, it only highlights the allowable soil bearing capacity of lateral pressure coefficients, etc. But no one is talking about the whole hill side stability. This is a similar problem to your dam problem when you add to existing stresses on the hillside. How do you think you can bring in this technology, how do you think you can bring this technology into buildings on sloping ground?
Vipul sir, probably in a few months, I can answer this question in a better position as one of my research student is on this problem. So the problem is already taken up and we are going to do the foundation, the building, RCC building, masonry building with the rock interaction studies. And few months I'll be in a better position to showcase you how we have integrated it and using the hybrid technology, how we are modeling the building and the foundation and then studying the interaction of both. So
yeah, thank you. I think I'm just skipping the questions which are saying excellent presentation, etc. and the like. There are many remarks like that. So I'm just in view of the time, I think we overshot, but I think we should finish in the next 5 minutes. Okay, one question from Mr. Khakodkar. This question is for all panelists. Sustainable construction is need of the hour, and one way of achieving it is going for structures which should have high service life without any requirement of repair or minimal repair. This requirement can be achieved by following durability-based design. My question is how we can start achieving it. I think we should start achieving it by applying it. That's all I can say. We have to start somewhere. If you are unsatisfied with it, please start with your own projects. Another question is, this is probably for Dr. Visalakshi, can cement be completely replaced by any sustainable material?
Yes, definitely. As I have shown in geopolymer concrete technology, it is a cement-free concrete. Okay, and there are various field application in Australia, which you can have a look at it, where they have used this technology to build the structures, not only the public structures, but also airports using this geopolymer concrete. So yes, definitely, geopolymer concrete with no cement content has a bright future.
Okay, then some anonymous attendee has asked how economical is GP, which I think means geopolymer concrete, as compared to OPC or PPC. Let me explain.
Yet
Yeah.
it's a very good question that if at all we want to use this technology for the field application, definitely it should be economical than the existing concretes. If you look into the economical cost of geopolymer concrete, the only cost which it incurs is the cost of the alkali liquids. Okay. Other than that, the materials which we are using are the waste materials such as the fly ash, whatever it might be. But the cost only goes into the procurement of the alkali liquids, which is a bit high at present. But if you can utilize the waste of soap industries which contain high alkali liquids, if you can refine the waste of the soap industries and use it, then definitely the geopolymer concrete would be much economical than the existing concrete. And also, if you want to use this geopolymer concrete in an economical way, then precast production would be the best solution to make it economical on par with the existing concretes.
Okay. I think we are coming to more or less a second last question. There are many more, but I think that since we cannot take up all the questions, we will transfer these to the presenters and maybe the reply will come.
Yes, definitely.
So there are unfortunately some questions which people have put in the chat box. Apart from saying good morning and all that, there was one question which I thought was interesting. Of course, they say, please share the presentation of slides. I think that, I don't know about that, but this particular session is being recorded, and IEA Structi will put it in the YouTube and share the link with everybody.
Yes.
Then they are talking about the from Mr. Ghai. The minimum cover mentioned in IRC 112 table 14.2 is 40 mm. Cover for precast pipes as per IS 458 is 8 to 15 millimeter. What about the minimum cover for precast RCC box? This is probably for Dr. Anil Sheth. That I mean, he's talking about the concrete cover.
Yes, sir. Yes, sir. So exactly that I put up in that presentation that was also our argument lot of times with sometimes also with the consultant, that if precast UM pipes have basically the idea of the cover is to have the corrosion protection, and what we understand it is, and some durability. It is not going to contribute too much to the structural as we see the diagram. And if precast UM pipes can have this less cover, then why should there be more? But then cover requirements is about 50 mm. I think I'll have to check the 40 mm and relaxable to up to 5 mm for according to IRC 112. Also, a lot of times
Yes.
it is being compared to 456. Sometimes it is also compared to underground foundations because these are underground structures. So then they have more cover requirement for foundation structures, or sometimes 75 mm they are specified. So these are all compared with various. Yes, my argument will be if UM pipes can have this less cover, then why not culverts? But I think there has to be somehow how the structural loading implications, because the form is different as to the pipe and the box. So only the form, but according to my understanding, that should not affect the cover requirement. So that is also my argument. So that was also what I found out in ACI 318, and similarly what we have in JIS. Incidentally, there is Japanese industrial standards also. Incidentally, there is also something called Japanese Box Culvert Association here that I saw, and they also have a cover requirement that is not more than 20-25 mm kind of requirements.
And of course, Ms. Kadam, there are so many people who have appreciated your presentation. I am still looking for a pinpointed question, apart from saying that it was fantastic, etc. And somebody has said wonderful digital efficiency, but I don't know where the question is. So
I understand, sir. Thank you very much. Listeners are also kind to appreciate the vast subject. And the two questions were there, which I have answered there.
Okay.
Yes.
One of them says very informative, enthusiastic, insightful, and inspirational presentation. Thank you, ma'am.
Thank you so much.
So, okay, so I think that we have come more or less to the end, half an hour late, but we have reached the destination. And as far as the concluding comments, I will take 2 minutes. I think that such events can inspire many women to come forward to actively participate in our deliberations. It will enrich our profession greatly. It is vital to have this inclusivity. There are many more women structural engineers, many of them who have already made a name for themselves, apart from the 4 ladies that we have heard today. And just to name a few, Professor Pratima Rani Bose, Alpa Sheth, Sangeeta Vij, and of course, Dr. Lakshmi Parmeshwaran. I think we hope that we will have more seminars like this, like webinars like this. And our president, Mr. Alok Bhaumik, will encourage this trend that he has started. There are also new people whom one has heard of, whom we are looking forward to making presentations. One of them is Professor Shashi Kala from the National Institute of Technology in Calicut, Dr. Sri Latha from NBKR Institute of Science and Technology in Nellore, and of course there are others from L&T following in the footsteps of Ms. Anamika. So with that, I think as far as I'm concerned, this session can be closed, but we will have the final word for the president to sum it up or go forward.
Thank you. Thank you, Professor Tandon. Such an excellent webinar. I think I must thank all the speakers, the eminent speakers, and I'm sure each and every topic which they have covered justifies one specific exclusive webinar for each one of them on each topic. And I think this is just the beginning. And as I mentioned, that in IEA Structi, we plan to have more such webinars where we would expect participation from the women engineers, because as Professor Tandon mentioned, we would like the women engineers to get encouraged and come forward. Many of them do such excellent work, but they hesitate to sort of come forward. And this is a male-dominated society where even the males also do not let them come in. So I think it is either way. Let me face it. Let me tell it very bluntly. This is a reality. So today we had an excellent, 4 lectures. What we learned, the takeaway for me, is that for a sustainable development, we need to embrace new technology. We need to talk of automation. We need to talk of artificial intelligence and its application in construction, as Ms. Anamika Kadam, demonstrated. We need to embrace new material. We need to talk about, because you see the cement industry is generating a lot of carbon footprints, and as per the Paris agreement, the cement industry has the task of reducing the carbon footprint by 18%, which is a very tall order. And it can only be done by using not only supplementary cementitious material, which we have been doing, but to use a new material, LC3, which Dr. Visalakshi talked about in great detail. And I think, in fact, that lecture of Dr. Visalakshi, we need a 1-hour lecture actually, maybe sometime later. We need to also minimize the material consumption for sustainability. Dr. Anil Sheth talked about the material consumption. And we also need to focus on the safety, sustainability. If we want to have a sustainable development, we need to talk about safety. And Dr. Shilpa Paul very aptly, talked about the dam safety, which is a very interesting lecture. I incidentally, I had given 2 lectures on Teton Dam and on Malpase Dam. One is Arch Dam and one is an earthen dam. And the failure history, which I gave 2 lectures, and it is very interesting. I have gone into great details of those, and very rightly, Dr. Shilpa Paul mentioned about the lack of interface between the structural engineer, the geotechnical engineer, and the geophysicist. And practically in majority of the dam failures, we find this problem. Most of the time, the failure occurs because of the lack of proper assessment of the geotechnical capabilities. And with this, I would like to close this session with special thanks to our great Professor Mahesh Tandon, whom we always lean for moderation. Always. We have 2 professional moderators in IAS Shakti. One is Dr. Harshvardhan Sumarao and one Professor Mahesh Tandon. And we always lean on them. Thank you very much, sir. And we close this session.
Thank you. Thank